Hello everyone, welcome back. In this lecture, I'm going to discuss the various types of operating systems as I have already written on the screen, so you can read out. These are few of the types of operating systems available. Now, the very first type of operating system I have mentioned here, the batch operating system. Then we will discuss multi-programmed operating system. Then time sharing operating system. It is also known as multitasking. And then we talk about the multiprocessing or multiprocessor operating system. Then real-time operating system and distributed operating system. There are other types of operating systems are also available, but primarily most of the books they cover these operating systems. So let's start the discussion one by one. The very first operating system, batch operating system, or we also consider it as uni-process operating system. So uni-process means there will be only one process at a time can be initiated, or you can say inside the memory there can be only one process loaded at a time. So in case you consider there is a RAM or memory is available, inside the memory apart from the operating system, there can be only one process at a time, uni process. Okay, so that is, let's say OS, and any of the process you are loading here, let's say P1. Single process can be loaded at a time. The problem in this, first cover all the properties. So it involves the collection of groups, or you can say the jobs. So in such kind of operating system, the programmer or operator were preparing set of jobs. So what is actually the job? The jobs were called as the combination of the instructions, which we consider as program, plus the input, which is expected to give to the program when the program will execute. So the input also was given in the beginning because the batch operating system was non-interactive. Once the batch has been inserted and the computer has start processing, the user were not capable enough to interrupt in between. And then some of the control information. So altogether these things we consider as a job. So the programmer or user was preparing the job and were having the flexibility to prepare a batch of job. But once the job or batch is prepared, so let's say a batch of job is here, which is having job 1, job 2, job 3, job 4. So you will consider the stack of job or pool of job is there. The processor will fetch one job at a time and start executing. Once this job will finish, then it will fetch. So let's say I'm saying processor or CPU allocation to the job. So it will be one after another. J1 will finish, then J2 will start. Once the J2 will finish, then J3 can be allocated and so on, right? So the drawbacks are very visible in this because a job, when it will be executing, it become a process, and every process requires two things. So if I consider the process life cycle, process is the combination of two things. It requires CPU cycle plus it requires IO, input output. So when one process is executing and it is consuming the CPU cycle, CPU is busy enough in producing the output. But when the process goes for IO, the CPU becomes idle and it reduces the efficiency of the operating system. Okay. So the batch of processing were used in a situation when a very large number of job or a large job is available, and the nature of job is such where user interaction is required minimal. Let's say you consider some task in, let's say, in Unix or Linux kind of system. We want to do the automatic backup, or let's say recovery or fault tolerance kind of thing. So some repetitive task we can schedule in cron job, and we expect that at a particular time the job will be automatically start, and there will not be any user intervention required, right? So such kind of jobs were planned in batch operating system, and they were getting scheduled, right? One of the example of such operating system or batch operating system is IBM OS2. Now in such kind of operating system, there were punch cards were used for taking input or punching the job. So the punch card were looking like this. There were a number of punch, and punch card reader was floating or the rays or light, and based on the light passing through, the bits were getting read. So let's say if light is passing, then maybe the binary 1 can be considered. If here the light is not coming, then here it can consider 0, and so on, right? Disadvantages we have already considered. The CPU cycle can be wastage. When the process is busy with IO, the CPU will become idle because next process cannot start until the first one will finish its lifetime. User cannot interact, it is the biggest drawback. So once the job processing starts, user interaction was not allowed, and context switching was also not allowed. Like one process in between cannot be interrupted until and unless it finishes the lifetime. So another cannot be loaded inside the memory. Only one process loaded in the memory. Then the next operating system is multi-programmed operating system, which overcomes the drawback of batch operating system. So in this operating system, at a time, multiple processes were allowed to be loaded inside the memory. So let's say this is your RAM, and inside multiple processes at a time can be loaded. So let's say here P1, P2, P3 kind of processes are loaded. There are multiple processes can be loaded. So let's say this is P1 process, P2, or you can say job, okay, P3 or P4. So more than one processes are residing inside the memory. That means degree of multiprogramming is more than one. In batch operating system, degree of multiprogramming was 1. Okay. Degree of multiprogramming. The degree of multiprogramming means the number of processes loaded inside the memory at any given point in time. Okay, so in such kind of operating system, there were flexibility to load a number of processes, right? The CPU getting allocated to process at a time one by one. So let's say process P1 get the CPU control and start executing the thing. So when it is consuming CPU cycle, the CPU is allocated to P1. But once P1 require IO, then rather than making the CPU idle, the process P2 or P3 or P4, the next process will get the CPU control. And this behavior will be controlled by scheduler. Okay, so that we will discuss later on. So that is there. So the context switching has been implemented, right? So when a process is leaving the CPU control and going for IO, then context switching can be performed so that another process can get the CPU control. So such kind of operating system provides such kind of features or properties like concurrency. Multiple processes can be executed in the same time frame. Concurrency means, let's say we are started executing the processes. So let's say this is the timeline I am creating, and the time is increasing in the downward direction. So here let's say P1 process is executing. and at next moment, let's say context switching has been happened here, P2 is executing, and then let's say after some time P2 has been interrupted for IO, then P1 starts its execution. If P1 start executing IO, then P2 will get the CPU control and it will execute like this. So within a time frame, let's say this is the timeline for P1 and this is for P2 process. If I consider this overall period, in this more than one processes are executing. So such kind of execution we consider concurrent execution. Okay. Then resource sharing is also there because more than one processes are loading in the memory or RAM, and at a time more than one processes are active. So resource sharing is there. Scheduling is required because more than one processes are there. So at what time which process will get the CPU control. Schedulers are also required. Memory management is required because multiple processes will be requesting for memory. Error handling is required. Such kind of system will be error prone because multiple processes are executing. So operating system need to implement, you can say, powerful error handling techniques so that there should not be any problem. Okay. Security is also required because system is allowing multiple processes to execute at a time. There may be malicious software or any problematic situation may occur. So error handling or security is also required. Interactivity is there. User can interact in between at real time when the task or jobs or processes are executing. Such kind of systems are flexible. Flexible like as compared to the batch operating system. Batch operating system executing the jobs in a sequential manner. There are very less flexibility, and it is scalable also in terms of the number of processes. It is scalable, and one of the example you can consider like Windows. Now such kind of operating system may have some drawbacks also. They may require a number of resources, like more resource requirement, and if a process is consuming resource for a very long period of time, let's say process P1, in this duration other processes are waiting, so there is no prioritized allotment of the job can be done. When this P1 goes for IO, so let's say here it requires IO, then at this point in time the processor can be allocated to some other process, let's say P2. So that is also one of the drawback. Implementation of such kind of system comparatively complex as compared to the batch operating system. Memory management will also tricky, and energy consumption, because there will be multiple processes running at a time, energy consumption obviously will increase. Now let's talk about the time sharing operating system. In time sharing operating system, we also known as the multitasking operating system. So there are certain properties I have written for multiprogramming operating system. In multiprogramming operating system, we were not allowed to schedule, or system was not allowed to schedule processes as and when it requires. The process switching or context switching will be allowed when one process, executing process, will release the CPU control and goes for IO. So there were less flexibility in that aspect. And this drawback has been overcome in time sharing operating system or multitasking operating system. In this, priority based scheduling can be implemented, or time sharing is implemented in this. Time sharing means if there are multiple processes P1, P2, P3, P4, system can allocate some fixed time quantum, let's say 1 second, 2 second, 2 unit of time, right? So first P1 will start executing. Let's say P1 is executing here. Now this is, let's say, equal to 2 unit of time. After 2 unit of time, the next process will get the chance to execute, let's say P2, then P3, then P4. In one go, only 2 unit of time is getting allocated. Maybe this P1 require more than 2 unit of time. So P1 will again get chance after every process executed for 2 unit of time. Then P1 will again get for 2 unit of time. If P2 is still residing in the memory, then P2 will get the chance to execute again for 2 unit of time. If P3 is also in the memory, then it will again get the chance for executing of 2 unit of time maximum, and so on. So this is time sharing behavior. Okay, it is more flexible than the previous system. In the previous system, when one process P is executing, until and unless it goes for IO, no other process can get the CPU control, right? So concurrency is there, resource sharing is there, scheduling required because more than one processes are there, memory management required because more than one processes are getting loaded inside the memory, error handling necessarily required, security is required, interactivity is there. So in real time, user can interact when the processes are running, user can interact with the system, flexibility is there. So this system gives the flexibility in terms of the setting up the time quantum so that the processes can switch. Scalability is there. Such kind of systems are scalable in terms of number of processes getting initiated in the system. Compatibility is also there. Such kind of systems are highly compatible. So can be work fine with different architecture, computer architecture. Time sharing I have already talked. Such kind of system supports multiple user initiation. So multiple users can be created and at a time multiple users can initiate their processes. And multitasking we have talked. So multiple tasks can be executed, right? And the example of such kind of systems are Unix and Windows NT, right? The drawback of such kind of system, or you can say time sharing system, almost similar to the multi-programmed system. Memory management is challenging. It requires more energy. It consumes more resources and so on, right? So let's talk about the next multiprocessing operating system. Multiprocessing operating system, actually, it is about having multiple processors. So if there are multiple processors or multiple cores available in a system, then there is a different kind of operating system required which can effectively utilize the multiple cores. So this is one of the category of that. And the prime feature of this kind of system, it supports the multiple processes or core handling, as I told you, supports for parallel processing. In this, real parallel execution of processes can happen. So within a time frame, let's say I'm considering again, this is the timeline which is increasing downwards. There are processes P1 and another process, let's say P2. At same point in time, more than one process can be active in the system. So here it is possible that one process P1 is executing on core 1 or maybe processor 1, and at very same time process P2 is also executing maybe on core 2 or processor 2. So if you look here at any point, let's say T0, if I consider this is moment T0, at T0 there are P1 and P2 both are active. This is parallel processing, not the concurrent one. Okay. So memory management is required and they provide effective memory management because multiple processes can be initiated. Inter-process communication is also implemented. These processes can communicate. Synchronization of the processes are necessary because when we are initiating multiple processes, we need to synchronize the behavior of those processes in order to maintain the consistency in the system. Load balancing. If there are multiple processors or multiple cores, on which processor how many processes are getting associated, this is also one of the role of the multiprocessing operating system. Scalability, because a number of processors can be handled or multiple cores can be handled, and number of processes can be initiated, and efficiency of the system will be more as compared to the other available system, and such systems should be fault tolerant. Examples like Windows, Linux and Unix, they can support multiprocessing if your processor supports that with the help of some features like symmetric multiprocessing and asymmetric multiprocessing features. So features are available. If your architecture is supportive to execute parallel processes, then such operating system can support it. The next operating system is the real-time operating system. So the real-time operating system, it is actually an operating system which initiate jobs, or you can say time-bound job. So in such an operating system, every job or process will have a deadline. If a process is getting finished within the deadline, then the system will consider the successful execution of the process. If a process finishes after the deadline, then the system will consider as a failure, right? So the real-time system incorporate the real-time scheduling. We will discuss later on when we talk about the scheduling. And inter-process communication or inter-task communication is implemented in this. Memory management they do because they initiate a number of processes at a time. Error handling is required. Interrupt handling is also there because if a process is not able to complete the lifetime within the time frame or deadline, then the process will be interrupted. Small footprint, these such kind of systems are small in nature. They does not consume much of the resources because they focus on the timely execution and the efficiency. Highly reliable. Such kind of system are very good in prediction. They intimate the user in advance rather than waiting for the end, and the job will not be able to meet the deadline. There are certain examples I have mentioned of the RTOS, VxWorks, QNX, and free RTOS is one of, or you can say these are the very popular real-time operating systems. This VxWorks operating system we use in multiple places where the very, you can say, hard-bound jobs are there. Okay, so this is one of the example of hard real-time system also. Let's look at, there are two types of real-time operating system. One is hard real-time, another is soft real-time. So what did I say? In real-time operating system, every process or every task is time-bound. Every task is time-bound. Okay, that means every task is having a deadline. So every process need to finish its lifetime within the deadline only. Otherwise, it will be treated as failure. If these deadlines are hard in nature, very strict in nature, even a, let's say, millisecond delay or cannot be tolerated, then we consider such kind of real-time OS is hard real-time operating system. Let's say missile launching system, okay, or rocket launching system. Even a second of delay will not meet the target, right? Then the soft real-time system like ATM system. So in ATM system, we insert our card, type the PIN, type the amount, and then we wait for the dispatch of the cash. So if it is getting delayed by 1 minute or 2 minutes, it is okay, or 3 minutes. So there is a deadline. After some time, it will reflect you timeout kind of message, but it is not that hard in nature, right? So let's discuss the distributed operating system. Now, what is distributed operating system? It is a kind of operating system which creates the environment on different computers. Those are connected through network. So it creates an environment so that all the systems make a single unit and they collectively perform the task. So such kind of operating systems are very good in terms of efficiency or throughput. So here I have already written a distributed operating system is an operating system that runs on multiple machines interconnected through a network, and makes them appear as a single unit or unified system. So this is very unique kind of feature which is having. There are other features like these systems are transparent. In terms of processes, when we allocate the task, wherever the task is getting processed, system is maintaining the transparency. Scalability is there. We can add more computers in a distributed system easily. These systems are fault tolerant. If anything is getting disturbed or there is a problem in one system, the task can be shifted to other system and the fault can be easily handled. Concurrency is there because there are multiple processors, multiple systems. Resource sharing is there. The prime requisite of a distributed system or distributed system came into the existence with the notion of resource sharing. So let's say there is a single printer and in a building we want to share it, so that from the very first floor I can give the command of printing, or the 10th floor user can also give the command on the same printer to print. So such kind of system. Nowadays you may share your printer on Google, right? So you are aware about this is also a kind of distributed environment which Google is providing. Interactivity is there, so user can interact at real time with the system. Load balancing is there, right? And replication of data may be there because there are multiple machines in the network. So in order to maintain the tolerance, or you can say the data corruption kind of thing, the data can be replicated on different machines. Examples we can consider like Windows NT server, Linux, and Google Chrome OS. And one of the important nowadays, you must have heard about Apache Hadoop. So these all are the example of distributed operating system. So this is sufficient for this lecture, guys. I hope you can remember all these different types of operating system. I'm closing this. See you in the next class. Thank you.